So let's do next. Let's change this configuration over to object groups. So let's go under the ASA and say show run access group. Let's create a configuration. I'm going to say conft clear configure access group, which means remove this line. And then we say clear configure access group, which means remove. We unfortunately cannot clear configure per interface. This command is going to remove all ACLs applied on any interfaces of the ASA in out. So it's not what you might want to do. Let's confirm show run access group. Show run access group. There we go. Next, we say show run access list. And we can say clear configure access list, and we should be able to put the specific name, which means clear the configuration of that ACL, which means remove all entries of that ACL, which means just delete the ACL completely. So if you say show run access again, the ACL should be gone. Now let's go on ASDM, refresh. We should see the ACL being gone in this section, and there we go. So now on the internet interface, we have 0 implicit incoming rules, so there's no rules configured as expected. And if you go under the ACL manager in here, we should see the ACLs are gone. So now let's achieve the same functionality now. So let's go now on the ASA. Let's do the same. Let's achieve the same functionality. Allow traffic between those subnets of type traffic of type SSH, Telnet, and HTTP. But this time we're gonna make use of object groups. So because we have in our ACL, if you looked what we had initially, so we had the 6 lines in our access list in here. And the only difference between the first set of 3 lines and the second set of 3 lines is the destination network, which in the first 3 lines is 172.16.10.0/24. In the second set is going to be 172.16.10/24, because those are our VLANs 94 and VLAN 92 subnets. So if you look at the configuration of the accesses, we can optimize this configuration. So the source of all of those 6 entries have the same source, VLAN 47. The difference between those 6 lines, those 2 sets of 3 lines, is the destination. And of course, on all 3 lines, we have the same 3 types of services: SSH, Telnet, and web. SSH, Telnet, and web. So we're going to configure one object group of type network to enhance the configuration and provide scalability. We're going to configure one object group of type network, and we're going to match on those 2 subnets. This is going to be a network type of object group, a network object group type. And also then we're going to match on those 3 services, which is going to be TCP services. We're going to match on those 3 services, SSH, Telnet, and HTTP. And we're going to combine those 3 into a service type of object group. So now let's see how the configuration is going to look like. In there, we're going to see the enhancement in the configuration part. And let's try and do that from the GUI. So let's say add ACL. The name is going to be likewise internet in. Okay. And then we click on that access list and we say add ACE, which means an entry in the access list. And if you look at the source, so we have in here the source criteria. That's going to be the source criteria. And here we have the destination criteria. So source destination. And to begin with, we have the action to permit or deny. So we want to, of course, provide a permit statement. And if we click in here on the source, So we want to permit. We don't have any object groups configured. We have some of them which the ASA allows you to create an object group based on the subnets connected to the ASA. I'm not going to make use of those, so I'm going to say add network object group. And as I stated, I'm going to combine in one object group of type network these two subnets. So let's go in the SDM and say group name is going to be, let's say, inside networks. And then we want to, so that's going to be the name of the object group of type network. And in here, we have to end up with what does the object group contain. So we want to add in there those two subnets. So it's going to be, we go in here and say create new object group member, new network object member, and we're going to put in there those two subnets. So say create is going to be a type not host but network. IPv4 is going to be 172.16.10 with a mask of slash 24. And then we say add. And likewise 172.16.10.0 slash 24 and say add. So now we've configured this object group with this name of type network and with those two entries in the object group. And we say OK. And we also want to add a service object group of type, of course, TCP, in order to match on those three services. So now we said we want to add an ACE, an entry in the accesses. The source is going to be VLAN 47. So we click on VLAN 47 and say, we click on this tab as source in here. So I'm going to configure one ACL entry with this source. I'm going to say OK. And destination, we click on destination and we put in the destination the configured object group. So we have in here in this section network object groups, which is the one we've configured before with a name of inside networks. There we go, the inside networks object group. We put that in the destination, say OK. And then we have to define a service. So in here, in the section, we're going to specify those three services of TCP, SSH Telnet, and HTTP. So it means we're going to click in here and we say add TCP service group. We give it a name to begin with. Let's say TCP inside services. And then we have to add in this section SSH, Telnet, and web. So we can look in the predefined in this area in the predefined set of services to see if we find all three of them and add them, and we should find them because those are known services. Otherwise you would have to say create new member and put in there the TCP port or range. So let's look for HTTP to begin with. There you go, it's HTTP, it's in here. We say add, now that's NNTTP. Let's look for HTTP. HTTP say add. And because port SSH and Telnet have consecutive port numbers 22 and 23, we can use for this a range. So we're gonna go in here and create new member and this section and put a range of 22, 23. So create new member, port range is gonna be 22 to 23. So all ports between 22 and 23 including, which means only the two of them. Say add and say OK. And now I want to use this as a service. So you have to scroll down in here at the bottom, and then you're going to see in there the configured service groups which we have defined. So I'm going to click on my service group and say service added in here and say OK. And now say OK. So what I'm saying now, if we read the ACL again, I'm saying I want to permit the action traffic from this source VLAN 47 to this destination, which means both of those two VLANs in my object group of type network, and of course only if traffic is TCP. It's included in that service object group of type TCP, which you know we added in there telnet, SSH, and HTTP. So let's say OK, and we say apply. But at this point, of course, the ACL is not applied anywhere. So we go under access rules again. We go under the internet interface, and we say add access rule. We should be able to apply it. Not in there. We should be able to. If you look on the ACL manager, so we've defined the access list, and then looking at the access rules on the internet interface, let's say refresh, should be able to say add access rule on the internet interface. Probably we should have defined the ACL from here, and then we also would have been able to apply it on the interface. So if we say add access rule on the internet interface, and then the direction, you would specify direction of in or out in there. So if we go under again in the ACL manager, probably we don't have the option in there. Let's say edit, let's say more options. Yeah, so in here in the ACL manager, you will go in here just to configure access lists, which like you don't necessarily apply them somewhere. Like for example, you do this for example for split tunneling, or for VPN split tunneling, or for VPN filtering, or for what else? I think those two. If you want to do any kind of redistribution and you want to match on something in the with an access list, you would go in there. Otherwise, if you would want to configure an access and also apply it at the interface, you should actually go under the access rules and add the ACL in there, and then apply also the direction. Let me look if we can actually look and match on the ACL in here. Unfortunately, it doesn't look like. So what we could do is we could quickly go under advanced ACL manager, and we just delete the ACL, but it's not going to delete the object groups. Delete the ACL, say apply, and then we go under access rules in here. We say we say add access rule on the internet interface, and we want to apply it in the inbound direction, And let's put again the source real fast to be VLAN 47. Okay. And then destination is going to be my object group of type inside networks. And then the service is going to be my defined service, which shows here on the top, TCP, say service, and OK. And then we say OK. And we say apply. You can also you can say tools and preferences. And you have a check in here which says preview commands before sending them to the device. This is useful if you would want to configure something on the ASA, you're not sure of the syntax, and you go and say preview commands before sending them to the device. You say OK, and then now when you've configured anything and you say apply, it's going to show you what commands is the ASA gonna enforce, gonna put in at the CLI level. So what you can save those commands to a file, for example, and you can re-edit them, because for example, as you're gonna see, the ASA has chosen an ACL name in there. For example, in this case, the way I define the ACL, it has chosen an ACL name of Internet Access N, which is not something that you may like, for example, because it uses both capitals and smalls in there, and that screams for trouble. You can easily do typos with that naming convention. However, let's leave it as it is now. Let's say send and say apply. And now if you look on the ASA, so if we say show run access list, now we have a single line configuration wise, so no longer 6 lines. We have an ACL named Internet Access N, which permits TCP traffic from the not interface internet. Let's re-edit the ACL because there's something. Let's say edit. So source, I said source to be the internet network, not the ASA interface. So source to be internet network, VLAN 47. Say OK, OK, and apply. Now let's look again in the ACL. There we go. So now the access list naming Internet Access N permits TCP traffic from source to VLAN 47 if it's destined to any destinations in that network object group, which we know we have 2 VLANs in there, and if it's a service type of SSH, Telnet, or HTTP. If you say show run object group, we see in there the network type object group, which with those 2 networks, and also the TCP service type object group with those 3 services, SSH, Telnet, and web. And show run access group, the ACL is being applied inbound on the internet interface, which means we should have the same allow traffic back and forward. But of course, if you say show access list, it's still going to show you the detailed version of the ACL. It says in here that you're going to see initially the first line, one line which says accesses internet access in, and then permit from the source to the service to the network object group and the respective services, and then it gives you a kind of like a detailed version of what does the ACL actually contain based on the configured object groups in there. So it is okay. We have only 4 lines because we use the port range in there. So if you look in here in the show access list, it says that traffic is allowed from VLAN 47 destined to 172.16.10 session 4 or a range of SSH and telnet. And then also traffic is allowed from VLAN 47 to the same destination of 172.16.10 session 4 if it's web. So we have only 4 lines now instead of having 6 of them, because we use the range option, which of course we could have used initially as well when we have defined the ACL without object groups. So as you can see, the main one of the main advantages, like configuration wise, is that you have only one. The ACL on short run is shorter in length. You see only one line, both in the ASDM and in short run. So instead of seeing 6 lines, you see only one line configuration wise. And second, of course, the other advantage is going to be that these 2 object groups can of course be reused in other ACLs. So that's why object groups add both flexibility to ACL configuration and also scalability, and enhances the ASA configuration there, because it's fewer lines in the ACL configuration wise. There we go, have only one line, and you can reuse those object groups in other ACLs, which means you don't have to recreate again the same object groups back and forward. So before we finish this topic, let's confirm that also traffic is being allowed back and forth now. So let's just test again, for example, that we can go from router 4, and let's see if we can telnet to VLAN 94, 23, and SSH to VLAN 92, 22, just to confirm that traffic works. So router 4, let's say telnet 172.16.10.1, Cisco. So if you say who, router 4 is connected, and on ASA2, of course, show connection detail. We see in the traffic, likewise, from router 4, random source port number, packet was routed on the egress interface of inside of the ASA, destined to router 1 on port 23, and session is up, and we have bidirectional traffic. And also let's SSH to the other VLAN, Cisco. If we say who, router 4 is connected, and in the ASA file state table we should see the SSH session now. So traffic from router 4, random source port number, destined to router 1 on port 22, which means SSH, and session is up, traffic both ways, and of course we have traffic being sent back and forth. So for the exam, I showed you both the ASDM and the CLI. So ideally, you should, of course, get comfortable with both the CLI and ASDM, because in general, a lot of troubleshooting, if you wanna become like an expert, go to the NP level or IE level, you at some point you have to go at the CLI and do any kind of troubleshooting back and forth. But for the CCNA exam, you should expect to get in the exam, if they give you simlets. So the simulations where you have to configure something back and forth, you should expect to get ASDM on the ASA. But of course, it doesn't mean you cannot also, they can give you CLI questions on the regular questions. Like they may ask something like, what is the let's say, how do you configure an access list to permit traffic from point A to point B? And then they give you the CLI syntax, which of course you have to know it. So try to meet both to know both the GUI, SDM, and the CLI. Even though SDM seems simpler, from my point of view, it's not a very good learning tool, because you don't see exactly what the ASA does behind the scenes, like CLI configuration wise. So when you have to investigate something or troubleshoot something, it's going to be way more difficult, because it's just, it's like a Microsoft thing. You say next, 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 you do some clicks, you hope it's going to work, and if it doesn't work, you don't really know what to do exactly. Because also in Microsoft, like the engineers, the experts, they go in the command line and troubleshoot. Of course, they also have, GUI tools to fix problems back and forth, but ultimately they go in the CLI, because also Windows has a huge CLI which allows a lot of investigations to be done back and forth.